Hello everyone, this is the first of a series of videos dedicated to redox chemistry. We're going to be looking at what redox chemistry is, what it means, what's reduction, what is oxidation. We're going to be talking about something called oxidation numbers or oxidation states and how we can use oxidation numbers to identify whether a reaction is redox or not. We will be looking at something called standard electrode potentials, what they are and why we want to use them. And we are going to use electrode standard potentials to predict if a redox reaction will be spontaneous or not. We're going to be looking at redox reaction in the context of organic and bioorganic chemistry, so in biological molecules or organic compounds. And we will see that although we can use oxidation numbers, other tools are more useful to identify whether a species, a particular compound in a chemical reaction involving organic compounds is, has reduced or oxidized. And finally, we're going to be looking at something called Pourbaix diagrams, PEPH diagrams, E being electrode potential, and we're going to use them to predict what sort of ions you might find in solution, ions that can stabilize more than one oxidation state, how you can use these diagrams to predict at different pHs what sort of ions of a particular atom you might find in solution. And as usual, this is not a series of videos aimed at students doing a chemistry degree. It's aimed at all of you doing chemistry as part of your other degree. If you have any questions, just drop me an email. Redox reactions are amongst the most common and most important of chemical reactions. All sorts of processes are redox processes, from the rusting of the iron, the process of respiration, the process of food browning. Something like batteries, for example, are based on redox reactions. Redox actually stands for reduction and oxidation. So in the same way as acid-base chemistry, for that to happen, an acid needs a base to react. In a redox reaction, it's actually, we are looking at two reactions. One, the process of oxidation, one of the chemicals in the reaction will oxidize, and the other, the reduction, one of the chemicals in the reaction will reduce. And what happens in a redox reaction is that electrons are transferred from one of the compounds to the other. And the compound that oxidizes is the one that is going to lose the electrons. So an oxidation reaction is a loss of electrons. And the compound that reduces is the one that is going to gain the electrons. And that's why it's very common in English language that people talk about oil rig. Oxidation is loss of electrons, reduction is gain of electrons. And again, oxidation and reduction must happen together. For a compound to gain electrons, it must be in contact with another compound that will lose the electrons. So as in the acid-base reactions, in which you cannot have an acid reaction, you cannot have something acting as an acid without a base accepting those hydrogen ions. This is about electrons. You cannot have a compound losing electrons if there is not another compound in the medium that accepts those electrons. So that's why we talk about redox reactions as a whole, but it's a specific, but it is, there are two reactions happening at the same time. One, the compounds losing electrons, and the other compound gaining those electrons. When an atom, an ion, a molecule, a compound in general loses electrons, we say it has been oxidized. And when, again, when an atom, an ion, or a molecule gains electrons, we say it has become reduced. And as I mentioned before, you cannot have an oxidation without a reduction, or reduction without an oxidation. They must happen together because the electrons lost by one of them are gained by the other compound. If we look at the exercise we have, the chemical reaction we have in this slide, you've got as reagents calcium metal. So calcium, a neutral atom, a neutral compound, and oxygen, O2, the molecule of dioxygen, which again is neutral. And they form calcium oxide as the product. And if you think of calcium oxide, is actually an ionic compound, and it's made of calcium, 2 plus ions, and oxygen with 2 negative charges. So if I look at the journey of the calcium, The calcium, as a reagent, was a neutral calcium. And when it becomes a product, calcium 2 plus, it has lost 2 electrons. So it has oxidized. And in the case of the oxygen, that was neutral as a reagent. When it appears in the product, appears as an oxide, as a negative ion, the O2 minus. That means it has gained 2 electrons.